Everyone, good morning. Welcome back to school once again. I hope you guys have been enjoying your weekend and I hope you've been enjoying your classes so far. Okay, so welcome to today's math class. Today's math class, I'd like us to be quick with a note and then do things. And let us say thank you to our proprietor and proprietress for making um these teachings possible, for providing all the necessary resources needed to have these classes. Okay, we say thank you to them. All right. And we say thank you to the teachers as well who have been teaching you all, in all your classes and all your subjects. Okay, we say thank you to them and God bless them. Amen. So for the past 1 week now, last week and then into this week, we've been talking about plane shapes. Plane shapes. 2 weeks ago, we started with the geometry of plane shapes. Then we came into the perimeter of plane shapes. And then we are now on the area of plane shapes. Okay. So, area of plane shapes, we started that last week um, in our class. And I remember last week I introduced you to the areas of plane shapes. You remember, then I introduced you, and then I we started area of plane shapes like irregular and regular shapes, and then we looked at rectangles, squares, and parallelogram last week. We looked at rectangle, squares, and parallelogram, yes, last week. And then this week we're going to be looking at the trapezium and triangles. Okay, I'm going to be looking at triangles and trapeziums today. All right. So basically, a quick revision. Remember, I told you that the area of any plane shape last week, that the area of any plane shape is the amount of space that the shape covers. Okay, the amount of space a shape covers is the area of that shape. All right, and then we looked at last week. We looked at units of measurements for area. We looked at the square unit, which is the only common used um unit for area. So no matter the unit of measurements that you make use of, and no matter the unit of length you make use of, it always has a square. Okay, even if you use centimeter or you use meter or you use kilometers or millimeters, it always would have a square. Okay, that is how to represent the area of any plane shape. Okay, and then also in our revision of last week work, I remember I showed you how to convert units of length, yes, unit of measurement for area. You get you know that 10 millimeters make 1 centimeter, right? Therefore 100 millimeters square will make 1 centimeter square. Okay, and I showed you how it is gotten. And then 100 centimeters make 1 meter. Therefore, 10,000 centimeters square would make 1 meter also. 1 meter square. Do you get it now? Like I showed you last week. And then 10,000 meters squared is equal to 1 hectare. Okay. And then 1 million meters square is 1 kilometer, because 1,000 meters make 1 kilometer, right? As I showed you last week. All right, and then area of rectangle being length times breadth, or length times width, depends on whichever way you want to use it. The area of square being um the length times its length, and times the length as well, right? Because all the sides of a square are equal, so all the lengths are equal. So you just do a length times length, or you say length squared. And then for the parallelogram, remember we said that the area of a parallelogram is the base times the height, right? The height of the parallelogram times the base of the parallelogram. Okay, so that is basically what the parallelogram is all about. All right. So moving on to today's work, I'd like you guys to know that for irregular and regular shapes, yeah, we started with for the regular shapes, we started with the rectangle, square, and then the parallelogram last week, right? So this week, like I said, we'll be looking at triangles and then trapezium. All right. So first of all, let's take a look at the triangles. For the triangles, look at this now. You see that in the figures you can see up there, you see that that first shape is a parallelogram ABCD, right? Now the parallelogram normally is the area of a parallelogram is base times height, right? The height times the base, all right, which you can see B times H, which is now you see that the parallelogram was cut in the middle diagonally from D to B or from B to D, whichever way you want to look at it. Okay, so you cut it was cut in by a straight line from D to B. Do you see now? Now the diagonal line BD divides the parallelogram into two equal triangles. Let me pick my pen now so I can mark them for you. You that now. So it divides it into two equal triangles, as you can see it here. Do you see that now? Huh? It divides it into two equal triangles, and that is what you see right here. Do you see that now? That's what you see there. The two equal triangles are there because the parallelogram, when you join them together, it forms the parallelogram also. You can see the both of them still carry the length of the shape of the base. Do you see that now? So this means that these two triangles ABD and CBD will now be to half of each parallelograms. Do you see now? Half of each parallelogram. Do you get it now? Half, half. So that means if you want to find the area of each triangle, it will be half of the area of a parallelogram. Do you see that now? As we have indicated there. Because each triangle is half of a parallelogram. Do you see that now? So the area of the triangles will be half times the area of parallelogram. So for the first one, this one, the half times the base times the height, because area of parallelogram is base times height. So when you do half times it, you have half times base times height. The same thing happens for the second triangle as well. Do you see that now? The same thing. Okay, so that is the area, that is how we got the area of a triangle. If you know the area of a triangle before, this is how it was derived. Okay, that is half base times height, half times base times height, meaning half of the area of a parallelogram. Okay, so that is just basically everything about the formula for the area of a triangle. Okay, so now look at these examples. Now look at these two triangles. We have the first one has a base of 11.4 centimeters and height of 7.2 centimeters, and then the second one a base of 10 centimeter and a height of 7 centimeters, and then we have to find the area. Simple, very simple. What is the area of a triangle? As we have seen in this place here, we know that the area of a triangle is what? Half times base times height, right? And that is 1/2 times what is the base for the first one? 11.4 centimeters times what's the height? 7.2 centimeters. Do you see that now? 7.2 centimeters, 11.4 centimeters. And then when you multiply both of them, you have 82.08 centimeters square. So half means you divide it by 2, right? So when you divide it by 2, you have 41.4 centimeters squared. You see that now? So for the second one, usually area of a triangle half times base times height. What's the base? 10. The height is 7. As you can see. Right? So and then when you look at it, you just use the half to cut the 10. 2 cancel, 2 in will go in 10, 5, right? So we have 5 remaining. So 5, as you can see here, 2 would divide 10, right? To give us 5. And then we have 5, and then when you divide by 7, you have 35 centimeters square, because we are dealing with area. It has to end with what? Square. Okay, because centimeter times centimeter will give us centimeters square. All right, good. Now look at this word problem. Okay, this is a word problem. Now look at this. The area, sorry, this, there is an a here. All right, the area of a triangle is 222 225 centimeters squared, right? And its height is twice as long as the base. Find the length of the base. Now this means that the okay, we know that the area of the triangle is 225 centimeters square. Now we're told that the height of the triangle is 2 times the length of the base. So let us call the base B, as you can see here. And then since the height is twice what the base, we have the height to be what? 2 times the base, which is the height will be 2b. So let's now represent that in the area of triangle. The area of triangle is half times base times height. We have the half, we know the base, but the height is what, according to this place, 2b. So we have 2b here, right? So now let these two cancel these two, right? So we have b remaining. So b times b gave us b squared. All right, so moving on, since the area of the triangle is 225, we represent that in this place here, in this place. So we put 225 centimeters square equals to b squared, right? Equals b squared, as we can see here. So b, the square will now cross the other side and now become square root. Okay, so that's why we have square root of 225 centimeters squared. The square root of 225 is 15. Okay, so therefore our b, the base, will be equal to what? 15 centimeters square. Okay, and then if you are told to find what is the height, since the height is 2 times the base, so that means 2 times 15, right? 2 times 15, and 2 times 15 is what? 30 centimeters. All right, so moving on, trapezium right now. Now look at this trapezium. This is one type of a trapezium. All trapeziums have the same area. Okay, you see that in this trapezium we have a cut here. We have area of a triangle, we have a rectangle rather, and then we have look at this trapezium. It forms a rectangle, it also forms a triangle, right? So we'll add the area together. So the area of the rectangle plus area of the triangle is what gives us the area of a trapezium. Okay, so now what is the area of the rectangle? Area of rectangle is the A times the height, right? That's the height in this case is the base of the rectangle, is the width of the rectangle. Okay, so this allows us to do A times H plus area of the triangle is what? Half times base times height. And what is our base for the triangle that we can see here? Let me show you now. Look at this triangle now. You see, this is the base of the triangle. The base is b minus a. So that's why we have b minus a here. And the height, right? All right, so ah plus half into b minus a, and then you expand the bracket with half times b times h. You have half bh, then half times a times h minus half h. Okay, all right, and then when you collect the like terms now, ah minus half ah, right, plus half bh. So when you do ah minus half, you know this one means 1 ah, so 1 minus half is half. You still now have half ah plus b half bh. So when you collect the like terms now, half will come outside, h will come outside, because half is common for the two of them. h is common for the two of them, so we have half and h outside into bracket a plus b. So we can say our formula for the area of a trapezium will be half into bracket a plus b times h. Let me remove the pen so you can see it clearly. Do you see that now in this place here? Let me circle it for you. Do you see where I circled just now? Do you see that now? So this place, oh sorry, so can you see that now? So that is the area of a trapezium. So moving on now, look at this second one. This is another type of a trapezium. Okay, and then it involves area of both triangles, adding them together. When you add the area of the two triangles, you find that both triangles, oh sorry, there is an h here as well. Let me write that. There's an h here also, because area of a triangle is half times base times height. So the base in the second triangle is a. Okay, all right. So because of this imaginary line that you can see here, all right, that's what allows us to have it as a triangle. Okay, so then we can therefore say that the area of a trapezium basically is half into bracket a plus b times height. Now let's look at examples. Now look at this example. Okay, look at this trapezium. Look at this trapezium. We have two of them there. Now a is the one up, a is the one up, b is the one down. Okay, a is the one up, b is the one down. This is your height, this is your height. All right, so the area of a trapezium, since it is half into bracket a plus b times height, you have half into bracket, what is our a for the first trapezium? We have 5 centimeters, and then we have 10 centimeters. Okay, so 10 plus 5, right, centimeters times the height, which is 6 centimeters. So when you add 10 plus 5, you have 15 times 6 centimeters. So 15 times 6 is 90, right? It's divided by 2, 2 divided in 90, we have 45 centimeters squared. All right, and then for the second one, 15 plus 9, we have 24. 2 can divide it 24, right, to have 12. So 12 times 5 will give us 60 centimeters squared. All right, so and then look at this word problem. We have the area of a trapezium is 81 centimeters squared and its height is 6 centimeters. Find the longer side or if the shorter side is 11 centimeters. All right, now let's look at this now. Area of trapezium. So we just represent the area of the trapezium. 81 centimeters squared equals half times a plus b centimeters times 6. So in this case, the 2 can divide the 6 to have 3, right? So 11 plus b. So divide both sides by 3. So 3 is cut here. So 81 divided, let me put this, I forgot to put that, divided by the over line, the fraction line. All right, so 3 here, 1, 3 in 81 will give us 27. All right, so we have 27 centimeters to be equal to 11 plus b, 11 centimeters plus b. All right, so making b the subject of the formula, 11 crosses to the other side and becomes minus 11. So 27 minus 11 will give us 16 centimeters. Therefore our b is 16 centimeters. That is how the base is gotten. Okay, so that is the end of today's class. Your assignment is on page 213 of your new concept mathematics. Okay, exercise 16.5. Exercise 16.5, question 1. You answer question A, question C, and question E. All right, so that is your assignment. Okay, to be submitted before the next class. All right, so thank you very much for attending the class today. Once again, I say welcome back to school. Thank you all for listening. I hope you learned something today in today's class. God bless you. See you in the next class. Goodbye.